Welcome back to part 7 of our exciting DIY autonomous mobile robot building series. If you missed parts 1 through 6, don't worry, you can find the links in the video description below or access the full playlist at the end of this video. Previously in part 6, after revealing my design, which resembles a duck, we started the design process using Fusion 360. Now we are at the plan view. I think it's fine to use a perfect circle for the top view of the head. I set the diameter to 75 millimeters. Put in a few dimensions here. Can't remember how I arrived at the dimension of 44.2 millimeters, but here it is. 40 millimeters on either side of the wheel should come in handy for sketching the mudguards or fenders. Again, applying the exact same method to sketch the mudguard and then mirror that about the centerline here. Carry on sketching the rest of the body. Here I am sketching the plan view of the tail. Then sketch the plan view of the bib and then the plan view of the beak. So that's all the reference sketches I think we'll need. Now it's time to create the actual body components. To do that, we'll first create a new component and label it head and hit OK. Next, select Create Form tool. Select Quad Ball from Create and select the YZ plane, or we could call it the side elevational plane if you want. Then select the center of your quad ball, upon which a spherical shaped ball appears, and set the diameter to 75 millimeters. We want to mirror all the changes we make on either side of the elevational plane, but before we do that, we need to set the visual style to shaded with visible edges only. Okay, so in the quad ball menu, we see the mirror symmetry is set to length symmetry and is indicated on the quad ball by the green line. However, that's the wrong plane. We want it to be aligned with the side elevational plane, which corresponds to height symmetry in this case. So we'll select that option on the menu and hit OK. Well, the spherical shape of the quad ball fits quite nicely, but we could do with a few adjustments. First, we select the Move Copy and move the quad ball down a bit. The quad ball seems to be in a good position here in each elevational view. To adjust the shape of the quad ball, you can select or left click either a contour line or a surface. I've selected a surface here and then right click and move the surface to fit the reference line better. So it doesn't have to be exactly the same as the reference line either. Here I am selecting a lower point on the quad ball. It's sometimes a good idea to swivel the design around to more accurately select the point you want. Swivel it back, right click and move the point upwards until it coincides with the reference line. You can likewise select other points and move them toward the reference lines in the same manner. Okay, the plan view doesn't look as though it needs any adjustments for the head. Next, we'll add another quad ball for the beak. We'll mirror the quad ball about the same side elevational plane, hit OK, and scale it up a bit. You can scale quad balls by selecting the center point and pulling it outwards. Okay, so you can select points or surfaces and move them toward the reference lines little by little. The beak is quite a different shape from the original spherical shape of the quad ball, so it will take quite a bit of work to get the right shape. You can hide the head for better visibility. Add a crease here at the back of the beak where it is to join the head by selecting these two faces, which automatically selects the other two on the other side of the symmetrical plane, and select crease from the modify pull down menu and then hit OK. Carry on moving the points and faces of the beak to fit the side elevational view of the beak, and then turn to the front elevation and do the same. And then from the plan view as well. Because the beak is such a complex shape, many adjustments will be necessary while swiveling between the different elevational views to make sure the shape works for each view. You can also use smooth on the modify pull down menu to iron out any surfaces that have bent out of shape. Anyway, after a lot of work, I managed to achieve the shape that I was looking for. For the neck, I initially chose this cylinder and shaped it very roughly in accordance with the reference lines. lines, but I ended up changing this design, so let's move on. Select another quad ball for the bib area of the body and allow it to mirror about the side elevational plane by selecting height symmetry. Start to move the lines, points or surfaces to the various reference lines little by little. This time we can create a crease along this line. Select all the lower surfaces and just hit delete. Then continue to adjust the lines and points until we get the shape we want. I also added a crease on the top portion of the bib and flattened that surface. Later on, I decided to fill in the hole that I created upon deleting the lower surfaces of the bib by selecting Fill Hole in the Modify pull-down menu. Next, we add another quad ball for the main body. Change the number of span faces to 3. Selected height symmetry again and spread it out to align with the reference lines using the same method. That is, selecting the points, lines or faces of the quad ball, right-clicking and moving the points, lines or faces to a desired position. It is, of course, necessary to check each elevational view while adjusting the shape. I've unhidden the wheels now, and here I am halfway through forming the left mudguard or fender using another quad ball. Once that is done, we need to hide the main body. Select Mirror Duplicate from the Symmetry pull-down menu and mirror this object by selecting this plane here and hit OK. Here's another quad ball for constructing the tail. Here I'm deleting 4 faces at the back, and then after finalizing the shape, select the lines along the edge of the tail, select Thicken from the Modify pull-down menu and give it a thickness of 1 millimeter. Okay, now to finish the tail we need another quad ball and squash it into shape using the same method. We don't want the front side of the quad ball showing through here, so we'll squash that in 2. I've actually copied the body components I've just constructed and saved them to a separate file labeled body shell to keep those components separate from the chassis components for now. Now it's time to combine all these separate bodies using the Combine tool. Select Combine from Modify. Select the head as the target body and the beak as the tool body, or vice versa is fine in the case of combining objects. Make sure that the operation icon is showing join, and also make sure new component and keep tools are switched off. We'll just inspect that by selecting section analysis and selecting the side elevational plane. And as we can see, the head and the beak are now a single integral component. Now we want to combine the remaining objects in the same manner, except we won't be doing the neck or the 1 millimeter thick tail portion for now. I actually made the mistake of not combining the mudguards or fenders before converting the body to a shell. This caused numerous problems when it came for me to slice the body and add wedge reinforcements later on. I made an extra copy to the right there because I was thinking of using that for vacuum molding, but I didn't end up needing an extra copy for that purpose. So here I am converting the body to a 0.5 millimeter thick shell. So make sure you combine the mudguards first and then select the shell tool to modify and set the inside thickness to 0.5 millimeters. Then do a section analysis from the Inspect menu, and as you can see from the hatched areas, we have a 0.5 millimeter shell for the body. To continue, click here for part 8. If the link is not showing, then part 8 is not quite ready but should be ready soon. Check out the description for my uploading schedule. Thank you for watching.